Hi guys, welcome to my YouTube channel. Today I will going to teach you how to make a data science project on a topic like breast cancer prediction. Breast cancer prediction is a specific task aimed at predicting diagnosis of a breast mass as either malignant or benign. The dataset used for this prediction consists of features computed from a digitalized image of a fine needle apparent FNA of the breast mass. These features describe various characteristics of the cell nuclei present in the image. And in the current dataset, which is look like this, has the ID diagnosis as malignant or benign, radius mean, texture, parameter mean, area smoothness, compactness, and so much more data types like you can see right here. So let's go to main basic part, how it will be done. We will take note of the basic parts as the ID number of each samples, then its diagnosis, target variable ingredient will be as M or 1 represent malignant and B or 0 represent benign. For each cell nucleus, the 10 real value features are computed, which are radius, mean, distance from the center to the point of on the parameter of the nucleus, texture, its gray scale value in the nucleus, standard deviation of it, then the parameter of nucleus, area of nucleus, smoothness of a measure of local variation in radius, lengths, compactness will be taken as the computed as the square of the parameter divided by the area minus 1, and its concavity describes the severity of the concave proportions of the nucleus contour right there, like a lump created right there, and its concave points represent the number of concave portions of the nucleus contour. And symmetry measure the symmetry of the nucleus right there and the fractal dimensions. This feature approximate the coastal line of the nucleus using the concept of fractal geometry. These features provide quantitative measurement that can be used to get characteristics of a cell nuclei and aid in distinguishing between the malignant and benign breast mass. Malignant means the mild type of thing or like a dangerous symptom, or benign as in a control situation like stuff. By we will going to use by training a machine learning module on this dataset, it is possible to develop a predictive model that can assist in the early detection and diagnosis of a breast cancer. First of all, as it the model importing take a lot of time, like you can see right here, 1 minute 8 seconds I have to do it before for avoiding the time waste. Okay, we have imported the NumPy, Pandas, and Matplotlib, and Seaborn as this. Then we will going to take the data from the read head part of it, as seeing what type of data set it has. Okay, so let's run it to see what it has in its data type. Like right here you can see it has its data frame right here, where it's all of the value has come here, and right here you can see it. Okay, then we will going to go to our next part of it, in which we will going to deploy the data pre-processing. In the part 1 we will remove the unnecessary column which has the unnamed or id, like here. Okay, by hitting this command. Then we will check the null values sum, like whether the data set has the any empty values like as a null right there, as we will going to take the df dot is null bracket that dot sum of it. Then we will going to execute it. It will going to show all of the part of the data set, whether it has the missing part or not. Right here you can see it has no type of an missing part. All of the type are integer types. So then we will going to take the data types, checking of it. It's for the further classifications of this data. Then diagnose will be as taken as the objects, radius mean as we are needed, font 64, texture same, area, and different type of stuffs like here you can see standard and concavity, worst, everything right here you can see. Okay, then then you can take the description of this part as this, take out its description, as it will going to show you the its count as the number of data set. It has the 569, each part has the 569, like you can see while scrolling right here. And this has given the mean of it, like as this is the value of it, mean, and then the standard deviations, minimum values, and 25% of their value, then 50% of their value, and the 75%, and its max value as this. Okay, then we have go to our next exploratory data analysis part of it. At first we have defined the depth diagnosis part, as which we have seen before in the data set, as it has been defined as the M, or M as the malignant and B as benign. Then we will going to correlate in the sorted value format. Then let's run it up for the future reference. Right here you can see a one more series has been created. So then we will going to create a bar plot for the number diagnosis of the number of diagnosis of the parts of it. So we have taken the plot for plot figure as figure size as 5 by 5, sine bar plot is bracket x is equal to df bracket diagnosis type of data which we have taken as the value counts, and index in the index, and phi is equal to df similarly value counts and in the values format. Okay, then we will going to run it, see what it will going to execute to us. Okay, now we can see right here it has given the like the number as 0 and 1 and its number of it. as you can see right here in the data set, we have the less severe cases than the more severe, as billions. Less severe ones represent the 0 and the milder and severe one represent 1 quantity. So then we will going to create a okay, hot map to check the correlation between them. For as this is a very big analysis of a total data set, so we will require the plot figure of the figure size as 20x20 and in the Seaborn format to get its okay, okay, different type of stuff as the df color and not is equal to true. So let's run it for the future references. Okay, as it that data is bigger, so it will going to take some time of us, like it already has the 1.6. So let me skip the part of it, then we will going to continue it. Okay, so guys, after sometime we have got our heat map right here, in which we can see it's a detailed format of it in the various type of content, as you can see as color as will be shown in the like the darker it is, the lesser its value, and different type of stuff right here, as one represents the absolute values, like here it is going to down, and then the is severe part like radius as this and different values right here, as it is a very big type of graph, so map, so you need time to understand it. So let's go to our model testing for these kind of stuffs. So we will going to divide it by using the mod library using sklearn model selection import trained test split. Then we will going to take the train xtrain xtest and pytrain and pytest as the variables. Then we will going to define it in the format as the splitting of them, df dot drop diagnose comma axis 1 diagnose. Okay, then the test size is equal to 0.3 and random state as is equal to 42. It is a good okay, stuff for increasing or okay, faster calculations, as its data is really a big type of, not that big, and it will going to show us the normal values. So let's wait there. Right here you can see it has created the some folders as this, like data frame series is right here, like the okay, then you will going to take the using the decision tree classifier method for the first analysis. So we will going to run it from the module using the tree and the fitting the x train and y train part into it. Okay, right here you can see it has created, but you can not always see it as these kind of stuff only can be viewed through a HTML representation. So okay, you have to check under the rendering, like a website can be view or organization. Okay, so then we will going to predict its data type right here where it is gone. Okay, then it will going to predict its basic part of data which had a key taken cross-checking, cross checking the key predicting value of with the actual value of the data set. So right here we have taken the predicted value above and then the test part of it. Okay, the format. So we will going to run it, and then we can see the stuff as like benign, malignant, predicted value as benign, malignant, malignant, benign, malignant, and benign 3 times. Okay, and then we will going to compare it with the normal value as it has the key 0 1 1 0 0 1 1, then an error in the actual value. So it can be happen in the any AI stuff. So that's where you can go to check its different type of accuracy part. So and last 0, and its data type will be as integer type. Then we have taken its all part of accuracy as this right here you can see, which is a relatively a very good type of a data accuracy, 93%. For in a such type of a data set, like in the credit card or a data set which is requiring the major part, you will need to apply on the higher success of this prediction, like around 95 or 97 around, and minimum as the 90 for its good data accuracy. Else if the data is too diversified, then it can be work with it. Okay, then we will going to take the logic regression method for it by the checking it. Okay, now let's run it. Right here it has created the similar part, like we have taken the decision logic decision tree classifier part. So in the same way we will going to create a prediction part of it. Then we will going to text again the sample on its test part, actual value parts. It right here, let's execute it. Okay, last part was not executed. Okay, not found. No problem. Okay, so now again let's just measure it. Right here you can see 0 double 1 same, 0 0 like 0 0 triple 3 and 0. It represents a higher accuracy than it, which means this logic regression method is way more good than the decision tree classifier method model for this kind of database state. So we will have done the key evaluation part. Now we will going to print its accuracy right here. Okay, right here you can see 97%. So in conclusion, we can see the if from the both of the models we can see that the accuracy is right here. We have to change the part right here. It has come to the second. It has come to 93 something sorry 93 93.5% means 94% at the round of figure. Means it is okay right here. Okay, means this accuracy is then the 97 respectively, but we can see the recall value for the regression of the regression as 97 percent, and which is the better than which we have see before. And okay, we can say that the logic regression method is better than the decision tree classifier. So okay, that's it for today guys. Thanks for watching my whole video. Okay, make sure you like and subscribe if you enjoy this. Okay, goodbye.